this presentation's on single chip series 10. So a lot of you may have heard me talking about SST, and that's this project.
Okay.
Yeah, you're right. It's
Okay,
toast.
here's what you do. Sit down here and hit the right-hand arrow.
It probably just needs a battery.
Probably.
Probably.
It's already done this way.
Oh. Okay, so
Single
hopefully this will
triple A.
work for the video folks.
Single triple A.
Okay,
But I don't
so
think
here's an outline of what I'm going to cover. I'm going to start with talking about Voyager, the Voyager program, to provide some context. Talk about the SST project, its goals, the HP organization what was going on around the project. Talk about the IC design team, the design description, design process and verification, some project surprises, and then we'll close. And if it doesn't look like we'll have time, so we'll skip the epilogue. I'll leave that for you to look at on the drive. So let's begin with noting that Voyager was a big deal for the Corvallis site. This is an HP internal employee newsletter, and the front cover of it has Dave Packard on it, but it says the star of the show was the HP11C. And I didn't add that graphic of the star on the calculator. That was a part of the newsletter. So what you're seeing is what went out to all the employees. So the calculator was the star of the show. And one of the internal articles in that same newsletter talks about how the Voyager series was covered on the local TV news channel as well as the industry trade magazines that you are all familiar with and are on our drive in several places. Now, what's interesting is as you go inside the cover, there's a letter from Ed Scheidler, the general manager of the Corvallis Components operation. So this is the manager of the IC fab that's responsible for building the electronics that go into Voyager. And this is his keynote that's going out to all the employees on the Corvallis site. And he says, Voyager's two major challenges for the Corvallis Components operation. The first is we need to do high pin-out quad flat packages. And that's a picture of one. I've got one over here at my desk if you want to take a look at it. The neat thing about these quad flat packs is that they're a whole lot smaller footprint than the standard dip of the day, and they're a heck of a lot cheaper than the Kyocera ceramic packages that were also available at the time. Then he goes on to say, Voyager required the largest CMOS chip yet done in our shop. And this is the quote out of the article that's right next to you. Even though this is too big for large-scale production in our present CMOS processes, we built tens of thousands of these circuits and made introduction of the new calculators possible months earlier. Okay, so are you getting the message? This is not something that they really wanted to do long-term production with. Okay, our new higher density MOS processes will be starting up early next year and will make our in-house capability cost effective. Remember that line. Okay. So SST project goals. By the way, is this working? Oh, you're still working on it. Okay.
Hoping for
SST project goals. Well, Voyager was doing well, even right out of the gate. Voyager was high volume for HP. So there was a lot of drive, as you just heard, to cost reduce the Voyager product and to reduce the number of ICs from 2 to 1 for the HP 10, 11, 12, and 16, and to reduce the number of ICs in a 15 from 3 to 2, and to use a 2-layer PC board. So to get down from high layer count PC boards to a cheap 2-layer PC board. Also, SST was viewed as a short-term cost reduction as Voyager was going to be replaced within 1 or 2 years. This is in 1980. Yes?
When you say 2-layer PCB, are you meaning just
Fiberglass top and bottom? or-
Yes, just one, a top and bottom layer of PC board.
Okay, so not two, fine.
Yep. Not, there's no inner layers on this PC board. Okay? So this is actually pulled from a brochure when the IC fab stopped doing ICs in Corvallis and we moved the IC fabrication to Fort Collins in Colorado. There was a big celebration called Bon Voyage for the people that were taking the fab to Colorado. And so this shows a timeline that's been redacted somewhat because it had some stuff in there that I couldn't present. From when the Corvallis site started in 1975, do people know why the Corvallis operation was in Corvallis? Okay. Well, first, HP had a program to diversify geographically. They were well aware that the Bay Area was sitting on an earthquake fault, and they didn't want the whole company to go down in an earthquake. So they wanted to diversify geographically. Second, they wanted to diversify geographically next to engineering universities. So that's why it's in like Fort Collins, Colorado, next to Colorado. Now, but why Oregon? Well, John Young, CEO HP, was an Oregon State University graduate. Okay.
Good reason.
So it's good engineering school. We worked with OSU a lot, and it had connections. Now another reason is that it was always the plan to have a CMOS fab, CMOS integrated circuit fab, to build calculators. The reason, and fabs are harder to build in the Bay Area than they were in Corvallis. So that was one of the things, this was a strategic decision to implement a very low leakage, low cost CMOS fab so that you could build these calculators that you don't need to change batteries for 5 years. Okay, so that was the plan all along. Now, on this timeline, I'm not going to go through all the detail, but another key date is around 1980. So when this started up, the fab reported into the calculator division. Okay, so it was all one business entity. In 1980, the site split out. So Corvallis division doing the calculators, PCD doing portable computers, and CCO doing the components. So CCO was a separate financial entity. So you just heard that the CCO general manager said in 1980 that, hey, I'm not making money on these components that I'm doing for Voyager. So this is part of the organizational context. Now, this is my view of the organization. These are what we affectionately called chewing gum badges. For the longest time, HP had these pin-on badges that was just as you see there. This is all of mine from the chewing gum days. I started in 1980 in Corvallis division, and I worked on the 75 and the 75 pod. So as I was finishing up the 75 pod program, the HP Voyager program had been kicked off and was underway. I joined Northwest IC division as a project manager, and my first responsibility was this SST project. So this is, as a brand new project manager, this was my first project. That's why I'm sort of presenting about it, because it was near and dear to my heart. Okay. So when I joined, what does this have to do with Return of the Jedi? So if you remember at the Return of the Jedi, there's this scene where Darth Vader lands on an incomplete Death Star 2, and he's greeted by the station commander. And the dialogue goes like this. Lord Vader, this is an unexpected pleasure. We're honored by your presence. You may dispense with the pleasantries, Commander. I'm here to put you back on schedule. Okay? I assure you, Lord Vader, my men are working as fast as they can. Perhaps I can find new ways to motivate them. Okay. I tell you, the station will be operational as planned. The Emperor does not share your optimistic appraisal of the situation. But he asked the impossible, I need more men. Then perhaps you could tell him when he arrives. The Emperor is coming here, That's correct, Commander, and he is most displeased with your apparent lack of progress. We shall double our efforts. I hope so, Commander, for your sake. The Emperor is not as forgiving as I am. Now, this dialogue I attribute down here to where I found it on the web. It's actually it's a treatise on project management and how this is a common situation that happens. So, as a new project manager for SST, I felt like both Vader and the station commander, depending upon which meeting I was in. Joining the engineering team, managing an engineering team that was behind schedule, I sort of felt as the project manager like Lord Vader stepping in, and I can tell you in my management meetings, I definitely felt like the station commander. Okay. As far as I need more men, well, SST had an international design team. I could not have asked for better as a project team. The Corvallis engineers, we had the HP41 CPU designer and several of the Voyager IC designers. We also had a group of Foreign Service Exchange engineers that were on long-term assignment in Corvallis. It's an awesome group of folks. Both BS and MSEEs. One of them went on to become the HP Agilent Penang site R&D manager. Another went on to become the Singapore site R&D manager. We had those folks became engineers, directors, and VPs at HP and other companies. So this was a top-notch group of folks. I've listed all the names I could find, and I reached out to 3 of the other team members to try. I think we're missing at least one name. And I apologize, I did make every effort to try to get all the names, because I appreciated everyone. We worked long, hard hours. We did not have lives, okay? We had a blast, and we formed friendships that lasted for decades. SST's design. Voyager schematic was hand-drawn on one E-size blue line schematic. The key tool used was that green logic template. That's the laser pointer up here. Was the HP logic template. And I actually still have one over at my desk.
Yeah, I do too.
So all previous designs for calculators were full chip custom layout. Okay, there was a fair amount of skepticism, especially in the calculator division, that it would be possible to do a standard cell design with the current CAD technologies and CMOS technologies of the time. A lot of folks didn't think it could be done cost effectively, get a die small enough. The SST design was partitioned into custom blocks, standard cells, and we had, we put the RAMs, now this is, the RAMs, the ROMs, the shift registers, PLA and analog were custom, and the schematic, we did schematics for standard cells. These are Calmo plots of the artwork that we generated. Okay. So this is a chip plot of a chip picture of the SST chip 1LQ9, I think, and it's the first single chip super chip for the 10, 11, 12, and 16. It's the first HP standard cell CMOS chip for calculators. I wanted a clean picture for folks' reference. This one I marked up with some of the details. The chip had RAM on it, ROM on it, a display shift register, the analog for the oscillator and whatnot, a coupling cap. We tried really hard to build a cap big enough so that the keep alive cap, when you take your batteries out, we could use that for that, and we just couldn't get a big enough capacitance. The phase lock loop for the CPU, the flip-flops. The process we had was a 1 layer metal, 1 layer poly CMOS process. Okay, so these new kids that use 8 layers of metal and 3 layers of poly, they don't know how easy they got it. That meant these long blocks are flip-flops, and that the poly and the metal, all the route channels were used, And so we affectionately called these routing obstructions when we were trying to do our place and route, because they were just big walls that you had to route around. You notice we got lots of routing up here. We could have substantially reduced the number of routes that we had, but we basically worked with the PC board designers to move these pad locations around to minimize the number of PC board traces. And you'll notice even some of the simpler pads seem to have logic around them, and a lot of that was for ESD and latch-up protection. We went extra heavy on making sure that we were ESD and latch-up protected. And I mentioned this to Eric before. I almost hesitate to mention this to this group, but we're the design team that was responsible for putting the Circle M and Circle C on the SST design. Circle C's copyright, and if you're wondering why HP kept saying, well, these are copyrighted, these ROMs are copyrighted, you can't copy them. Well, we did that to you.
So Chuck, question about that, was that in the wake of having had other knowledge of other IP being reused, or was it looking forward to?
This was looking forward. We as a new semiconductor operation, it was standard we were afraid, like MaskWorks, we were afraid that knockoffs in the Far East or somewhere else, they may come along and just copy the mask to pirate some of the design work. So that's why the Circle M's there. The Circle C it was becoming standard practice. Is that the way you would protect your software?
It's been well discussed that the 41 doesn't have it.
Yeah.
And then the next ones did. I was just wondering if there's a relationship there, or if it's just you guys said, hey, we should be doing this.
Yeah, we just said we need to be doing it.
So the Circle M mask protection, that came about to the Semiconductor Mask Protection Act that Congress passed. It was not thought previously that copyright would be applicable to this sort of work, although some people tried, but that was made law that it does. And actually the first chip that ever did that was the DEC Microvax chip. But HP clearly was in on it reasonably early after that act passed as well. I would point out that all the Voyager ROMs I dumped were from the original Voyager hardware that did not use this chip. and part of that's practical. I don't actually know how to dump the ROM out of this chip.
And there is a way. So verification. During design, we did full chip simulation. The test vectors for this part, for those that are interested in on the IC design side, were all functional test vectors. So this was before scan test. So these were all functional vectors. And Voyager was running in volume at a very low PPM rate. It was in single or double digit PPM rates, which was very good at the time. Okay, so we had a high confidence that if we took those test vectors and used those to verify the design, that we were doing good. We used HP Spice, and no, not the bottle of Spice over there. HP had its own version of Berkeley Spice, which had tuned models for its internally developed CMOS processes. We used Scopes, the Sandia Controllability and Observability Program, to evaluate testability, and we ran DRC and LVS on an AMDAL in Loveland, the same one that they ran the books on for HP. It took 3 days to run a DRC on the part at the time.
What's DRC?
Design rule check. It's an artwork check, so they check the widths and spacings of all the lines in the design. And LVS is layout versus schematic. Is a way to check your schematic versus the artwork. During manufacturing, we used Schlumberger Sentry 7s and Sentinels for testing. We did full pattern, functional pattern testing, electrical spec. We did multi-pattern RAM retention and ROM verification. For prototyping, we did large build proto builds. We handed those out in mass to everybody, a lot of people on the site, not everybody, but a lot of people on the site, and asked them to beat on the units to try to find stuff. We also had technicians verify every user manual example for all the models. So they literally, pulled up the 12C manual, 11C, 15C manual, opened it up and walked through every keystroke that was in any of those manuals.
The size wafers were these built on, the size, the size semiconductor wafers,
I think it was 3-inch.
3-inch.
Okay. So, Bob, thank you. Bob got me a picture of a
It looks better here.
Bob got me a picture of a pre-Voyager calculator inside. Okay, it has 2 ICs, it has 2 PC boards, an FR4 board down here, and a polyimide board up here. Polyimide boards are more expensive boards. They have the same thermal coefficient of expansion as silicon, and so I got an old calculator board where we do chip on board, where you put the chip down on the board and you bond it, and then you put epoxy over it. You use polyimide for that. So it had the 2 PC boards, plastic protection on the top. It had wires, and it had components, and those 2 PC boards had a connection. So that's what a Voyager looked like. SST. This is the SST system. 1 chip, 2-layer FR4 PC board, the Keep Alive cap. We tried also really hard to get the resistor and the oscillator, the resistor and capacitor for the oscillator on chip. Couldn't do that either. So those are those 2 components. And there's a spring over here. You notice there's a notch in the PC board. The spring went from the metallized overlay on the keyboard to the metal back case. And what that does is that builds a Faraday cage around your electronics. Portable systems are awful for ESD because a regular calculator, a regular computer has an AC ground, okay, which is you can connect your case to the AC ground. Portables don't have that ground, and so what you have to do is you have to build a cage around, and that's the way we did it. So this is a fairly clean system.
Hey Chuck,
Yeah.
did anybody ever suggest not using gold on your platings for the plating, PC board plating? Did they ever suggest as a cost reduction?
It was talked about, but quality was job one.
Yeah.
So it didn't go far. Okay. So project surprises. Well, the big one, as you already know, is that the HP 12 was not obsoleted by Pioneer and is still going strong today. So the HP 12 outlisted its fab process a couple of times over. SST was not the last Voyager reimplementation. Another project surprise is we were surprised at how less robust the semi-custom auto place and route designs were than their original custom designs. Okay, and what we found is that HP Spice was very accurate when we had all the parasitics in there, but the simulators at the time didn't allow us to have enough of those in, and so we missed some timing races and whatnot. And this computer doesn't have the font. It's too bad. So on your drive, okay, you will see that a display of one example that was found late was, you guys know what on period does on a Voyager? It changes from decimal point to comma. Well, there was a timing race on one of the terms, okay, so that, you remember I said that somebody went through all of the steps of the manual? Well, all the people that we handed it out to on the site, nobody found this, okay, but the tech that was going through the manual steps did an on period, and all of the commas in the display lit up, along with the numbers, due to this timing race.
Good test, display test, right?
So this is actually one of those units, okay, and I've got it at my desk, okay. Now, this is a marginal unit, but it's working. Can any of you guess why? That haven't looked at the presentation already.
Low batteries.
That's the key. So that little star, for those of you familiar with the Voyager, indicates that it's a low battery. Well, this, I unhid the label that's on the unit that says that this is a unit that operates at 2.7 volts. Now I'm going to ask you, now we know how it's doing it, well, or why it's working. So how is it working?
The race condition changed.
No. Again, the key is that little star. Okay. Okay. This is that unit. Okay, so first of all, this was a 15. So now we've got 2 chips, and then the rest of the components are the same as the 12. And then there's something going on over here in the battery compartment.
Only 2 guys.
Okay, I'll do a blow-up view. Okay, so that's a nylon washer with a diode draped over it and a battery on either side. So 1.5 volts plus 1.5 volts minus a diode drop gets you a voltage that the calculator works at.
But it's not, it should be designed for 3 or 4.5, right?
Well, I said that this was a marginal unit that had a timing problem, and so we did. You have to get the, anything you can do to work around the marginality so that you can have people continue to bang on it to make sure there aren't any other things behind that first layer of the onion is really important. So that's the way we did this.
Yep. I've used that trick many times.
Chuck, the people you had tested, you said just people around, were these engineers who were designing calculators, or these people who sweep the floor, or
Marketing, engineering, manufacturing, quality,
just anyone?
just
Don't beat on this kind of thing.
it wasn't the janitorial staff or the security staff, but it's just about anybody else that was fair game.
Now, were they compensated? I don't know the right term, but I mean, what motivated them to spend some of their time trying to do it?
Because people like to play with them.
Okay. Same as
No,
us.
we didn't get anything special, but I mean, it was, a lot of them also got to keep them. So,
Did they find any really good bugs? I'm always curious about that. Did
No.
random employees? No? Well, I mean, were you looking for logic bugs, or it's still working kind of thing?
it's still working.
Okay.
What we're trying to do is verify that we hadn't broken anything in the re-implementation, which we found that we did.
Now, did you have an NMOS process going before?
Oh, thank you for asking. In that timeline, I showed that we brought up CMOS. On the web, there is a YouTube video out there that says that Voyager was implemented in SOS, and they said the reason that was silicon on sapphire. And Corvallis site has never had
Yes.
sauce. There may have been other products, and even maybe some early design stuff was done in silicon on sapphire, but Corvallis has never had CMOS. Instead, it had a custom designed CMOS process that's actually talked about in one of the HP journals. Okay, that was set up for low cost, 1 layer poly, 1 layer metal, and ultra low leakage. And so it was ideal. That's why the calculator's batteries last so long.
I thought that kind of misinformation claims that certain things were made out of sauce CMOS that weren't in non-HP products as well, and generally, with rare exceptions, sauce was primarily used for military stuff
Yeah.
because it's inherently radiation hard.
Or space.
And it's expensive,
which
too.
was
Yeah.
still a radiation issue.
Yeah.
But some RCA products, there were special versions made by Sandia Labs that were sauce, but the standard RCA product was not. And so I've seen, this same kind of misinformation happens
And
various
that's
places.
That's actually another good point. At this time, in the 70s and early 80s, okay, I want to remind you that at that time, Japan, where a lot of the integrated circuit stuff was done, was all NMOS. Okay, the only people in the world doing CMOS at the time, other than this fab, was like RCA, and that was one of the reasons why HP got into the CMOS fab is that they needed this technology in order to build this product line.
HP,
Yes.
HP did use some silicon on sapphire in some products in other divisions, and it was early on. It was before calculators went to CMOS, and it's basically a very expensive process. So the non-silicon on sapphire stuff was called bulk CMOS, and that's what all normal stuff used.
Also, for higher frequency uses also, right?
I'm not sure.
So, in sum, I walked through the Voyager context and challenges. We talked about the project, the IC design and its development, and the project surprises. So, that's what I had for you. Any questions?
What is SST?
Single chip Series 10.
Oh,
So,
okay, yeah, right.
Voyager was Series 10 product line, and this was for the 12, 10, 11, 15, 12, 10, 11, 16, it was one.
Oh, famous, all right. Just
Yeah.
renowned for that.
How much per unit cost savings did the re-implementation save?
I'm not at liberty to say.
As much as you were aiming for?
Oh, yeah. Like I said in my summary, this project that was supposed to only, at the time we were told over and over again that this didn't make any sense to do this project because this project was going to be obsoleted by Pioneer. I mean, there was a strong belief that Pioneer was going to be substantially better and going to wipe out Voyager within a year. And that never happened, and so, oh yeah.
Yeah, it's so far off, I mean,
Yeah.
So when you pick up a Voyager, how can you tell whether this is the SST or predated SST from outside? Is it obvious, or is there any signs that tells you which one? It is?
You can look at the date code on the bottom of the calculator. Also, if you don't have springs, if you've got metal tabs, metal tabs on the battery contact, that would tend to indicate it's an older model because most of the SST units have a spring on one side.
Most, or?
I won't say all because I can't promise. I think it's all.
I think it's all, yeah.
I think it's all.
What's the cutoff?
Yes,
What's
Jay.
the cutoff date?
If you think, if they were saying that Pioneer was gonna wipe out Voyager, why, can you speculate as to why they never tried to do a 16C successor in the Pioneer case?
I can't speak to the
Yeah, it's
thinking
kind of
and
weird
marketing
thinking about it
and
now.
Corvallis. Sorry, you had a question?
You mentioned that you could look at the date code. What would the cutoff date be? After which date would they be SST? Approximately.
Bob would be a better guess than I.
Don't know. I'd have to look at a big pile of them at home. It's sometime in '82, I think.
Yeah.
Okay,
It's sometime in '82. Anything '83 or later, definitely.
be SST.
Corvallis only did CMOS?
Corvallis only, well, until it didn't, it only did
Oh,
CMOS.
I mean, but that's the end, or anything.
Well, no, that's not, I'm not gonna go through all this, but, so for what happened in Corvallis, B3 was the first fab that was done. B2 was brought on as a higher volume, lower defect density, higher performance fab. It also was only CMOS. So both of these fabs were only CMOS for when they ran.
Nothing else was ever done in Corvallis?
Well, I'm going to answer that. Okay, so down here, by the way, HP at one time offered foundry service to supercomputer companies. I can name a few companies off video for you that you would not believe, but they actually bought semiconductors out of this fab because at the time it was one of the higher performance fabs. And almost every graphics card designer used HP silicon out of Corvallis. Now HP transitioned from doing internal CMOS ICs to being a foundry service customer from TSMC and some of the other foundries that you're all familiar with. And now to answer your question, they shut down B3 fab, but they transitioned to B2 fab to be inkjet head manufacturing. So it's still there, it's still running, and still cranking out inkjet heads. Oh yeah,
I thought they moved.
So the HP site, I'll go ahead and talk about it briefly. When I joined in 1980, there were 3 buildings, 3, 4, and 5. And 5 was just complete, and we played Frisbee on the upper floor because there wasn't anything in the building. Okay. The rest of the site was outfitted over time. This is a picture between 1980 and current. This is the current site. The current site, HP is still there in Corvallis. They're not gone, but they're not occupying all the building. The site is now a business park. And so HP still got the big B2 fab running. They own the cafeteria and several of these buildings. But there are other things on the site now. The folks at Polycom that do the Polycoms, they were there. There's a nuclear reactor startup, so small scale nuclear reactor design companies on that site now. This is Anami, this is advanced technology. This is a company that's using Inkjet to do things like to basically take the Inkjet technology and the picoliter drop dispersal power of an Inkjet technology to do things in medicine and that kind of stuff because that's what Inkjet does, is it delivers picoliter drops precise to precise locations, and you can use that for industrial printing, you can use that for medical sampling and all sorts of other things. So that's what's going on the HP
So
site.
you worked with Bill Wicks then?
Oh yeah.
So I don't remember what year it was, but I was privileged at one point to get a tour of what was going on at the time by Jim Donnelly after he was no longer working on calculators. And so he was involved with some of the stuff with web presses. But so one of the things that's made there, unless it's changed since then, is that the site was not primarily a primary producer of inkjet cartridges for printers. What they produced was inkjet cartridge factories. So the inkjet production lines were constructed and tuned up and tested and got operational at that site, and then loaded up onto a 747 and shipped somewhere else in the world to be reassembled to be an inkjet cartridge factory. It was just absolutely fascinating seeing one of those lines, and I'm actually really surprised that I was able to get permission to see it.